Have you ever wondered which graphics API produce the best visuals and performance? Are you curious about how these APIs shape your design experience? Or perhaps which platform they support? This video will go through the most known graphics APIs, what they are used for, and where they're most commonly found, so that you can pick the one that suits you the best. And before we move on, why should you listen to me? Well, I'm Oskar Schramm, a professional game programmer specialized in graphics, and I have over a decade of game development experience, so I kind of live, eat and breathe game development. Let's kick things off with the two main pillars in graphics programming: OpenGL and Vulkan. OpenGL, often known as the grandfather to graphics APIs, targeting cross-platform compatibility, and is an excellent choice for your project if you want to target multiple operating systems. On the other hand, we have Vulkan, the new kid on the block, offering lower level access and enhanced performance. Titles like Doom Eternal and Red Dead Redemption 2 utilizes Vulkan's capability to deliver breathtaking visuals across multiple platforms. Turning our attention to the realm of Windows development, Microsoft DirectX is the pure winner here. DirectX 11 remains a popular platform for Windows and Xbox development. Titles like Halo Reach and Forza Horizon 4 are great examples of what DirectX can achieve. Just like Vulkan was the new kid on the block for OpenGL users, we have DirectX 12, which does the same but for DirectX 11 users. Games like Gear 5 and Cyberpunk harnesses all the low-level accessibility you gain from DirectX 12. Now for the developers that are stuck in Apple's ecosystem, we have Metal and Molten VK, which are both tools for Mac OS and iOS development. Metal, Apple's proprietary low-level graphics API, offering optimized performance and tight integration to the Apple hardware. Games like Infinity Blade and Monument Valley, and a lot of the graphics APIs you're using on your phone right now, are made with Metal. Meanwhile, Molten VK acts as a bridge between Vulkan and Apple, making Vulkan be able to run on Apple products. This integration has supported porting popular titles such as Dota 2 to the Apple ecosystem. Now to the ever-evolving landscape of web graphics, we have WebGL and its successor WebGPU. WebGL, rooted in HTML5 and JavaScript, enables developers to render 3D objects directly within the web. Although not as popular as before, just as with Flash, WebGL is still used for most of the 3D rendering in webs today. And as the same pattern as before, we had OpenGL and Vulkan, then we had DirectX 11 and DirectX 12, and now we have WebGPU, which is just a lower level, more optimized, and it works with more things and so on and so forth. Now we're coming into something that's really fun and that's on the rise for the last couple of years, and it's something that I wasn't aware of that stood out from actual graphics APIs, and that's parallel computing APIs. Because GPUs are built to run in parallel, it's a really good thing if we can use it for more than rendering, and that's where all the parallel computes APIs come into place. The first one is CUDA, developed by NVIDIA. You might have heard about CUDA when doing video encoding and stuff. CUDA is used a lot in machine learning AI, but also in image processing and video compression. Applications that you might not think of directly, but uses this are OBS and Adobe Premiere when they actually image compress things. On the other hand, we have OpenCL, which is not, as we discussed before, an accessor, but it's actually a substitution to CUDA. This is because CUDA can only run on NVIDIA cards. OpenCL tries to enable a broader perspective on it to not only target NVIDIA platforms. So now we're moving into console-specific APIs, and most of them are actually not open source, which is why we cannot really gather information about these. For PlayStation developers, we have libgnm and GLM, which serves as the primary graphics APIs, albeit with limited accessibility outside of PlayStation developer kits. Games like The Last of Us and Grand Theft Auto are two examples. Moving on to Nintendo Switch. You can develop for this on both OpenGL and Vulkan, but they have their own low-level optimized graphics API called NVN. Just as for all the other specific graphic APIs, It's to target a specific hardware, and that's just what NVN is doing for Nintendo Switch. As technology and games becomes better and better, we need to amp up the graphics APIs, but we cannot produce graphics APIs all the time, and therefore we have bridges in between, and these are called extensions. NVIDIA Optics stands as one of the most powerful backbone in between these bridges, and it supports a lot of games, but also a lot of films right now. Additionally, we have extensions such as VKR or DXR, which are both extensions for each platform to enable ray tracing on a hardware level. So when trying to choose a graphics API that suits you, be sure to know which hardware limitations you have, which platform you want to publish to, and if you want to do rendering or computational things, and also if you want to go low level or high level. And remember, just because a graphics API can achieve higher performance with a lower level optimization, that doesn't mean that if you import the new DirectX 12, you're just gonna gain the performance. You have to actually implement the low level things for it to be greater than, for example, DirectX 11. And because of that, I think it's way more important to choose which graphics APIs actually you want to learn, but also what your project really needs. If you don't need that performance, don't go with Vulkan and DirectX 12. Stick with OpenGL and DirectX 11. And when picking which graphics API to choose from, it's good to know your hardware specific features of your GPU. From DLSS to XESS, it's important to know how these impact your game developer experience. That's why I've made an entire video breaking down video game settings, what they do, and where they can actually give you performance. So if you're interested in that, be sure to click up here right now.